In this brief video, we're going to take a look at calculating molar masses of chemicals and diatomic elements. So in order to do this, you're going to need access to your periodic table, of course, and you're also going to need a calculator handy. So we're going to take a look at how we can calculate the molar masses of the following examples, some of the following examples. So let's take a look at the first one. We do have a diatomic element here, chlorine. Now this is important. The subscript 2 is important. Let's pick a different color so this shows up a little bit better. So the subscript 2 is important in this diatomic element. It's not just chlorine, Cl, that we're calculating the molar mass of, but Cl2. So what the subscript tells us is that in this molecule, Cl2, there are 2 chlorine atoms. Each chlorine atom, if I take a look at my periodic table, each chlorine atom has a molar mass of 35.45. That's 35.45 grams per mole. And we have two of them in this molecule. So 35.45 times 2 of them, that gives me a molar mass of 70.90. And again, the units for molar mass would be grams in 1 mole of Cl2 atoms. So if I had, for example, 6.02 times 10 to the 23, which is what a mole is, 6.02 times 10 to the 23, which is a huge number again, 6.02 times 10 to the 23 Cl molecules, so 2 Cl's joined together, this would be the mass of 1 mole, 70.90 grams, or 70.90 grams per mole, grams in 1 mole. Let's take a look at an example now that involves some different elements. So once again, to work our way through this, we're going to take a look at the individual elements that make up this compound. So in potassium hydroxide, I've got 1 potassium, and I can take a look at my periodic table and see that the molar mass of potassium is 39.10 grams per mole. So 1 mole of potassium ions would give me 39.10 grams. So I'm just going to write grams per mole as my unit here. 2 would be the second element, pardon me, is oxygen. And I have, let's just keep it in the same order, I have 1 oxygen here as well. Okay, so in this compound, I've got 1 oxygen. So I'm going to take a look at my periodic table, see if I can find the molar mass of oxygen. There's 1 of them. The molar mass of oxygen is 16.00. There's only 1, so I just need to keep that number. The last element in this compound is hydrogen, and I have 1 hydrogen. The molar mass of hydrogen is 1.01 grams per mole. So now what I need to do is I need to add these up. So you can whip out your calculator. We got 39.10 plus 16 plus 1.10 should give us, well, let's see if we can do it without a calculator. That gives us a 1 here, a 1 there. That's 16, 3 and 2, 5. 56.11 grams per mole would be the molar mass of potassium hydroxide. All right, let's take a look at a more complex one. Let's scroll up a little bit and take a look at this one, number 11, because we've got a complex ion and it's in parentheses with a little subscript outside. So that's going to make it a little bit more involved, our calculation. So when we take a look at this compound, which is ammonium sulfate. Here's the ammonium, and there's the sulfate. When we break that down, we need to think about how many of each atom are in there, and this subscript is going to become very important. This subscript, this is like in math, where if you've got a coefficient outside the brackets, everything inside the parentheses is being multiplied by that number. So for example, the 2 here is going to mean that we have 2 n's. All right, so we're going to have, we'll have quite the list. So let's see if we can do this one up in this section here. So we're going to have 2 n's in this, 2 moles of nitrogen in this compound. I know that on my periodic table, nitrogen is 14.01, so it's going to be 2 times 14.01, which gives me a total of 28.02. Again, all of these are in grams per mole. Okay, so all of these, the units here, are grams per mole. The next thing I'm going to take a look at is the 2 outside, again, is being multiplied by H4. So I've got H4, and I've got 2 of those. So that's going to give me a total of 2 times 4 is 8 H's. So it's going to be 8 times the molar mass of H, which is 1.01, and that's going to give me 8.08 when I multiply that. Again, grams per mole. Now I'm going to take a look at what else I have. I've got just one sulfur, so that's 1 times sulfur. I'll take a look at my periodic table, and sulfur is 32.07, so that's going to be 1 times 32.07 should give me 32.07. Lastly, I take a look at, I've got 4 oxygens, so that's going to be 4 times oxygen, and that's going to give me 4 times, we'll take a look at my periodic table, oxygen is 16. So 4 times 16 is 64.00. Now I can find the sum of all of those. Looks like 17 there. That's going to be a 1 there. 8, 10, 18, 22. We'll put a 2 there. And 2 up here. 2, 4. That's 10 and 13. 132.17. Again, the units for this, grams per mole. Okay, maybe see if we can scroll through and find one more example. Again, let's take a look at 13. Here's another example that involves a complex ion and parentheses around it. So let's just see if we can expand this a little bit. This is where we'll do 13. So let's start with our Pb. I've got 1 mole of Pb in 1 mole of this ionic compound. So 1 times, and again I'm going to look at my periodic table, find Pb on the periodic table, and write down the molar mass of Pb. All right, so 207.2, so it's 1, only 1 mole of Pb. Now I'm going to take a look at my parentheses. See, I've got 2 moles of N. So 2 times whatever the molar mass of nitrogen is. So that's 2 times 14. It's the molar mass of 14.01, pardon me, is the molar mass of nitrogen. That's going to give us 28.02. And then we've got 3 times 2 is 6. 6 oxygens. All right, so it's going to be 6 times oxygen. So that's going to be 6 times 16. So that should be, I believe, 96.00. Now we can do our addition. I think that's going to be 22 6 and 8 and 14, that'll be 21. Put a 2 there. 9 and 2, 11. That'll be 13. So 331.22 grams per mole. All right, that should give us an idea of how to calculate molar masses of ionic compounds, or really any compound, because we also did chlorine, which is a diatomic molecular compound, and we've got some other examples of molecular compounds on here as well.